Have you ever pondered the meaning of cross-validation in the realm of data science? Well, strap in, as today we dive into unraveling the mystery of this vital concept. Cross-validation, in the simplest terms, is a technique used to assess how well a statistical analysis will generalize to an independent data set. It's a way to predict the fit of a model to a hypothetical validation set when an explicit validation set is not available. Now imagine a scenario where you have a set of data and you want to construct a predictive model. You might wonder, how can I ensure this model will perform well with new data? And this, dear listener, is where cross-validation waltzes in. Cross-validation works by dividing the data set into two sections, a training set and a validation set. The training set acts as a playground where the model learns patterns and makes initial predictions. The validation set, on the other hand, acts as a testing ground to evaluate the model's performance. Here's how it works. First, the model is trained using a portion of the data set. Once the training is complete, the model is then used to predict the remaining part of the data set, the validation set. The predictions are then compared to the actual outcomes, and the model's performance is evaluated. Now, you might be thinking, what if the division of the data set was unlucky and the model didn't get to learn from the most important examples? That's a valid concern. To tackle this, the cross-validation process is repeated several times, each time with a different division of the original data set into training and validation sets. This process is known as k-fold cross-validation. In k-fold cross-validation, the original sample is randomly partitioned into k equal-sized subsamples. Of the k subsamples, a single subsample is retained as the validation data for testing the model, and the remaining k1 subsamples are used as training data. The cross-validation process is then repeated k times, with each of the k subsamples used exactly once as the validation data. The k results from the folds can then be averaged to produce a single estimation, ensuring a comprehensive understanding of the model's performance. In essence, cross-validation is a robust method that helps ensure your model's predictions are not just a lucky guess, but are based on a systematic and repeatable process. It helps avoid overfitting, where the model fits the training data too well but performs poorly on new data. It also helps in model selection, hyperparameter tuning, and getting an idea about how the model will generalize to an independent data set. To sum up, cross-validation is a powerful technique that allows us to estimate how well our model will perform on unseen data by using our existing data more efficiently. It's a crucial part of building reliable and robust predictive models in data science. Remember, the goal of cross-validation is not to create the most accurate model, but rather to create a model that generalizes well to new data. After all, the true test of a predictive model lies in its performance on unseen data. So, the next time you're building a model, don't forget to cross-validate. It might just be the difference between a model that merely looks good on paper and one that truly shines in the real world. And with that, we've demystified the concept of cross-validation in data science. It's like a trusty compass guiding us through the wilderness of model building, ensuring we stay on the right path towards creating models that truly work. Until next time, keep exploring, keep learning, and remember, data science isn't just about the numbers, it's about understanding and telling their story.